All right, let's get right into it. The science of musical chills. We're going to talk about why your brain absolutely loves a good beat drop and what's happening inside your head when that one song gives you literal goosebumps.
You know exactly what I'm talking about, right? That amazing tingle that runs up your spine, the hairs on your arm just standing at attention. It happens during that perfect chorus or that incredible buildup. Some people call it frisson, but we all know it as the chills. It's your body's way of screaming, yes, this is it.
And here is the central puzzle. Think about it. Why does a simple sequence of sounds feel as good as things we actually need to survive, like food, or things we're driven to get, like money? It doesn't really make sense on the surface. Music is totally abstract. It's just sound waves, after all. So why does our brain treat it like a winning lottery ticket?
To figure this out, we have to put on our detective hats and dive into the brain itself. So let's investigate the mystery of musical chills.
Every good mystery needs a prime suspect. And for us, that suspect is a little chemical called dopamine. You probably heard of it. It's the brain's feel-good chemical, the little reward signal that says, hey, that was great, let's definitely do that again. It's the force behind our most basic motivations. So the big question was, is it also the reason we love music?
Well, that's exactly what a team of scientists at McGill University decided to find out. They put together a really clever experiment to see if they could catch dopamine in the act, to see if it really was the secret ingredient that makes our favorite songs feel so incredible.
So, how in the world do you spy on a brain that's listening to music? Let's take a look at how they set up this whole experiment.
Okay, so here's how they pulled it off. First, they found people who were guaranteed to get chills from certain songs. You know, their absolute favorite, goosebump-inducing tracks. Then they put them inside some powerful brain scanners, PET and fMRI, to watch their brains in real time as they listened. And just to be extra sure, they also measured physical things like heart rate and breathing to confirm exactly when those chills were hitting. Pretty smart, right?
And the verdict? A huge, resounding yes. The brain scans, just like the one you're seeing, showed a flood of dopamine being released right in the brain's reward center. This was the smoking gun. It was the first time we had concrete, physical proof linking that amazing feeling from music directly to a dopamine rush.
But, you know, that massive discovery? That was just the beginning. Turns out the data was hiding an even cooler, more complex story. It wasn't just about one reward. It was a tale of two.
And here is the big plot twist. This is what made the study so groundbreaking. The dopamine rush wasn't just a single event. It was actually happening in two distinct parts. It wasn't one reward, it was two.
Okay, take a look at this. These two scans show us everything. The image on the left, that's the brain before the chills hit. That's all anticipation, the buildup. The image on the right, that's the brain during the chills, at the moment of peak pleasure. And you can see it, right? The bright spots are in slightly different places. That was the crucial clue.
This two-part process is really the heart of the whole thing. So let's break down exactly what's going on during the anticipation phase versus the peak pleasure phase.
So it all boils down to this really cool two-part system. First, there's the wanting phase. That's when you're listening to the song, and you know the best part is coming. Our brain region called the caudate nucleus starts pumping out dopamine. It's the thrill of the chase. Then, when that beat drops and the chills finally hit, that's the liking phase. A different area, the nucleus accumbens, releases its own surge of dopamine. That's the pure euphoria of the reward itself.
And they had the numbers to prove it. The scientists found that the more chill someone expected to get, the more dopamine activity they saw in that wanting part of the brain. It's the neural signature of looking forward to something amazing. More anticipation equals more activity.
And on the flip side, the more intense the chills actually were, the more activity they saw in that liking area of the brain. This perfectly confirms it. One part of the brain handles the pleasure of wanting, and another part handles the pleasure of getting.
So what is the big takeaway from all of this? Well, it tells us something fundamental about the power of abstract joy, and why something like music can have such a profound effect on us.
This quote from the scientists themselves just nails it. They say that artists are constantly playing with our expectations, building tension, delaying the payoff, all to make that final resolution even more powerful. In other words, your favorite musician is an intuitive neuroscientist. They're experts at manipulating your brain's wanting system to make the liking payoff feel absolutely explosive.
So let's just boil it all down. What's the crucial point? Well, music hijacks the exact same ancient reward system our brain uses for things like food and survival. And it does it with that clever two-step process.
the pleasure of wanting, and the pleasure of liking. This is exactly why the journey of a song, with all its tension and release, feels so addictive. And really, it helps explain why music is such a universal and deeply important part of being human.
And that kind of leaves us with one final big question to chew on. If our brains can get so much pleasure from something as abstract as music, what else are we wired to enjoy? What about the joy of a great story, or looking at a beautiful painting, or even just solving a tricky puzzle? Are all of those experiences tapping into that same ancient system of wanting and liking? It makes you wonder what other amazing things we're built to love.